All right. First thing we talked about in the chemistry unit was history and structure of the atom. History is far less important on the final exam than it was on the unit exam. Structure is the important part. Okay, so let's mostly say structure of the atom. Okay, on your unit exam, you were asked to draw me a picture of an atom of, I don't remember what it was, lithium or something like that. Okay, in order to do that, you had to be able to calculate the number of protons, number of neutrons, the number of electrons. Okay, and then give me a picture of the correct model, which is the electron cloud model, right? Those kinds of things. That stuff's still important. Probably not a written response item, probably a couple of multiple choice items on models. Okay, like the current model, mostly calculating number of neutrons, number of electrons, that kind of thing. So using the periodic table. Okay, so so make sure you know those. Okay, be able to do that. Other things that you're going to need to be able to do in terms of structure is current model. Okay, where are the particles, nucleus, okay, all of that kind of stuff. So your kind of general knowledge of the structure of the atom will be tested, and that'll be almost entirely, almost exclusively in the multiple choice section of the final exam. Evan.
Were the guys that did who discovered the different parts of the atom, the one guy who discovered?
No, I already said that. History is not important.
Okay,
structure is. Okay. All right. After that, we went into naming. Naming is obviously a fundamental skill for the chemistry unit. If I'm giving you a reaction to write out and I write it out in words, you need to be able to turn the names into formulas. Okay? But there could also be just a few naming questions in the multiple choice. All right, so we'll need to remember things like when to use Roman numerals. When do we use Roman numerals? When it has more than one possible charge, which means that only applies to certain metals. Okay, there are no non-metals that have more than one possible charge. Okay, so we would be looking at things like iron, cobalt, copper, okay, things like that. They would have more than one possible charge. Okay, so that's when we would use Roman numerals. So if I give you this formula here, okay, and asked you to write its name, this would be iron, okay, Roman numeral 3, chloride. Almost wrote oxide, chloride. Right, and I know that it's the 3 because chlorine's -1, and the compound has to have a charge of, all compounds have a net charge of 0. So there's 3 negatives here. That means this has to be +3. So I write Roman numeral 3 in the name. Right, again, that only applies to metals that have more than one possible charge. Okay, you got to be able to write formulas. So you got to be able to do drop and swap. Okay, that's a crucial skill as well, because again, I could just give you a reaction that's written out in words, and if you don't get the formulas right, you're not going to get it balanced right, you're not going to predict the products correctly, okay, all of that kind of stuff. So, man, naming is so important. Okay, it is a basic fundamental skill that you must have a mastery of in order to do well in the chemistry unit. Okay, if that's something you struggled with, best start practicing it. Right, because it's going to be really, really important. Okay? Even for the mole equation, if I write out the name of a compound in words in the mole equation question, you won't be able to do those correctly either, okay? Without being able to do the naming. All right. Okay, so naming. And that's both ionic and molecular compounds. Okay, we got to be able to do both. Now, with ionic compounds, charges always have to balance, but in molecular compounds, they don't. Okay. And in molecular compounds names, we use something we don't use in the ionic, which are prefixes. Okay, little things like that, but it would be advisable to review your naming, practice a few of the naming ones from the many worksheets that we had available to us in the chemistry unit. Okay, I'm saying you have to go through every single naming question that I gave you before. Don't do that. Okay, pick a few at random off of those sheets. If you can do them, then you're good. Okay, you don't need to spend hours and hours on naming unless it's something you don't get. And if you're spending hours and hours on naming and still not getting it, that's probably something you should come in and ask for some help on, right? Because there's other things you need to spend hours and hours on. Naming's probably not it. Okay, I can probably help you with that and fix that quickly. All right, after naming, then we looked at properties of compounds. We did a lab on this where we had to identify unknown compounds based on just their physical properties. We did a solubility test, a conductivity test, a pH test, observable properties, okay, all of that kind of stuff. There will definitely be some multiple choice questions about that. Okay, so maybe you have something like you are given an unknown sample that is a clear, odorless liquid that is highly soluble and has a pH of 7. Its possible identities are A, sodium chloride, B, ethanol, C, butter, D, water. Okay, it probably wouldn't be that easy, but you get the idea, right? I would give you a description of something and you would have to follow the same set of steps you followed in the properties of compounds lab. Okay, well, it's not ionic because it's a liquid, right? It's got no odor, so it can't be like ethanol. It's a neutral pH, so it's not an acid, it's not a base. Okay, those kind of things. Everyone follow there? So exactly the same procedure you would have gone through on the properties of compounds lab. Expect probably a couple of those just to review that ionic compounds have these properties, molecular compounds have these properties. Okay, then we talked about solubility and the polar nature of water. Okay, so there could be obviously some multiple choice about both, okay, about both solubility and polar nature of water. Those multiple choice questions could include using your solubility chart. After all, I did put it on the formula sheet. All right, so maybe I give you a question that says, here's a chemical reaction, reactants, products, which, if any of the products are soluble, and then you would have to look up on your solubility chart the products and see if any of them are soluble, okay, and that would be that, okay. Also, remember terminology to do with solubility, things like precipitate, because I will use those terms, okay. And we had to do in our reactions lab, we had to use the solubility chart to figure out which of our products were precipitates and which weren't. Okay, so expect that you'll see that. And then obviously heterogeneous and homogeneous solutions, okay, or mixtures, right? We need to know what those are. Okay, things like that, just terminology that we talked about in that unit. Be familiar with it so that when I use it in a question, you know what I'm talking about. And then polar nature of water, okay? What happens in a polar molecule? What makes a molecule polar? We haven't started reviewing yet, have we? Okay. If something is polar, that means it has two ends that are opposite. So, in a molecule like water, which is shaped like the mascot of an evil corporation.
It is totally evil.
Okay, I'm just kidding.
It is evil.
A little bit. Okay, yes, it's Mickey Mouse, exactly. Yeah. All right. So for the water molecule, okay, we have that the two hydrogens. Okay, so this is oxygen here. Okay, the two hydrogens are positively charged, while the oxygen atom has essentially two negative sides to it. Okay, because the electrons are not shared equally. Okay? They're shared, but they're not shared equally. They spend more time down by the oxygen molecule, or sorry, oxygen atom, than they do up by the hydrogen atoms. So one end of the molecule ends up being charged positively and the other ends up being charged negatively. What that can lead to is hydrogen bonds, which would be if another water molecule, okay, came by, it could form a weak bond with the oxygen atom on a neighboring molecule. Those bonds are not really strong. They break easily, but they reform easily, and they are responsible for some of those weird behaviors of water, like surface tension, okay, cohesion, and adhesion. So lesson 7 is one of the few lessons in chemistry that you need to read the notes over a few times, because there will be a number of multiple choice questions about polar molecules. Okay. All right, then we started talking about reactions. What number are we on here? 5. Okay, reactions. There's only a couple of multiple choice questions about reactions. This is very much weighted towards the written response. Okay, there are 3 written response items that are like, here's 3 reactions, balance them. There are 4, here's a chemical reaction, predict the products and balance it questions, okay, in the written response. So are those kind of big ticket in terms of marks? Yeah, all right. Each one of those reaction questions is 4 marks. So there's 16 marks in just that one question that has the 4 parts. It's got A, B, C, D. Okay, 16 marks in that question to do with predicting the products and balancing, okay, for a chemical reaction. Right, so big marks there. We definitely want to be able to do that. So when we talked about reactions, we talked about 5 different types of reactions. We talked about synthesis reactions. Okay, what happens in a synthesis reaction? Okay, so 2 things are taken together and combined. Let's be a little more specific. Those 2 things are usually going to be elements or compounds? Elements. All right, so we could have like sodium plus chlorine makes sodium chloride. That would be a synthesis reaction. Is that reaction balanced? It is not. Okay, so I need to balance it. I start with what's present in the largest number, chlorine. I put a 2 over here. Now there are 2 chlorines on both sides, but I need to put a 2 over here to make sure there are 2 sodiums on both sides. Now the reaction is balanced. Okay, definitely something you're going to be asked to do in the written response part of your final exam. Okay, what else? We talked about decomposition reactions. What happens in a decomposition reaction? Yeah, a single compound breaks down. So we would have like right, something like that. Magnesium oxide breaks down into magnesium and oxygen. Remember that if you're predicting a decomposition reaction, you may produce a special element that requires a number on it, right? Okay, like oxygen's always a 2, sulfur is always an 8, phosphorus is always a 4, right? Those kinds of things. So keep those in mind. This reaction is not balanced. I have to put a 2 there and a 2 there. Right? Then we talked about combustion. Combustion had a lot of special rules. Right? So if we have what were always the products of a combustion reaction? Water and carbon dioxide, right? Okay. There were special balancing rules to do with the combustion reactions. Anyone remember what they were? Luke? Right. If I have an even number of carbons, I start my balancing with a 2. We called that the rule of 2. What was the other rule? Right. Balance in alphabetical order. All right. So 2 times 4 is 8. So I need an 8 here. 2 times 10 is 20. 10 times 2 is 20. Now I can balance the oxygens. On this side of the reaction, I have 8 times 2 is 16 oxygens, plus 10 more is 26. 13 times 2 is 26. I would expect to see a combustion reaction. Okay, we went over lots and lots of them. They do have their own special rules, so okay, that's probably something I would test.
What do you usually go with then?
I'm not asking you to write the names. Okay. All right. Then we have the 2 types of replacement reactions. So, single replacements. Okay, remember that replacement reactions always involve ionic compounds. Okay, ionic compounds in elements or just ionic compounds. There are never molecular compounds in a replacement reaction. So a single replacement reaction could look something like this. All right, NO3 is what kind of ion? It has many atoms. What's the prefix for many? Poly, like a polygon is a many-sided object. So these are polyatomic. Okay, they have many atoms, polyatomic ions, right? So this is a polyatomic ion, right? And when we write them in, if we're writing a name, we write the name exactly as it appears in the table of polyatomic ions, right? So this is copper plus silver nitrate gives me copper 2 nitrate and silver. How did I know this was the copper with the 2+ charge? Because it didn't tell me that over here. It's the most common, right? So if I don't know for sure, I go with the most common charge. All right, so I've got this reaction, and right now it is not balanced because there are 2 nitrates on this side. Okay, how many nitrates are on this side? 1. Okay, right, that 3 is part of the nitrate. Okay, so I need to put a 2 in front of this. Now I have 2 nitrates, but now I have 2 silvers. So I need to put a 2 there, and now everything else will work. All right, questions on single replacement? Okay, and then we had, lastly, double replacement. So that's 2 ionic compounds. All right, so I have potassium permanganate, KMNO4, and it's reacting with calcium chloride, CaCl2. Who is going to be potassium's partner over here? Chlorine. Okay, remember, I swap the metals. I can't have 2 metals together. I can't have 2 nonmetals together. I can only get ionic compounds on the other side. Okay, so that's KCl, and that means that calcium has to end up with permanganate. Okay, this is a -1 and that's a +1, so that compound is okay. But this is a -1 and this is a +2, which means I need to put brackets around the permanganate and put a 2 there. Now I need to balance the whole reaction. So I'm going to start with permanganate because there's 2 over here, and I'm going to put a 2 here. That gives me 2 potassium, so I'm going to put a 2 here. That makes my chlorines work, and now the reaction is balanced. Okay. All right, questions on how those work? Okay, if there's one thing you should spend a significant percentage of your time working on in preparation for this test, it is reactions. Okay, the two things from the chem unit that are going to be worth the most marks on the final are reactions and the mole equation. Okay, in terms of problem solving, things like that, those questions basically make you remember everything about the unit. Okay, they make you do naming, they make you do balancing, they make you do reaction types, they do all of that stuff. So, okay, that's what's going to be on there the most. Okay, after reactions, and we did a lab on reactions as well. Okay, where are we at now? 7, 6. Then we did the mole equation. How many different ways were there for me to ask you a mole equation question? 4. Okay, did I go over multiple examples of each one? Yes. Advice: watch at least one of the podcasts of me going over how to solve each of the types of mole equation problems. It wouldn't take you that long to watch one of those, and it would be time well invested in your preparation here. Okay, so things to do with the mole equation. Being able to calculate molar mass. Okay, in order to calculate molar mass, I've got to be able to write the formula correctly. So if a question told me that I was dealing with, let's say, calcium sulfate. Okay, I've got to go, okay, so calcium is Ca, and sulfate, is that S or SO4? SO4. If it was S, it would be sulfide. Okay, so this is SO4. Now, because this is an ionic compound, I've got to drop and swap. All right, well, they're both 2s, so we're good the way it's written. Okay, now I need to calculate the molar mass. So I look up the mass of calcium. Okay, 40.08, and there's only one calcium, so I only need one. Okay, sulfur, 30. I never remember sulfur. 32.07. Okay. And there's only one sulfur. And then there are 4 oxygens. Right. I put all those together and I have big M, the molar mass. Remember, the mole equation is number of moles equals mass in grams over molar mass, which is going to be in grams per mole. Okay, so we'll have 40.08 plus 32.07 plus 16 times 4. Okay, so 136.15 grams per mole. All right, so that's how I calculate molar mass. Now, maybe the problem asked me what the mass of, well, we'll write a problem so you have an example here. So let's say I got that problem there. Right? So it's calcium sulfate. We've already calculated its molar mass. Okay? They want to know what the mass is, so I'm looking for little m, of this many molecules of that material. Okay, so I already have big M, but I need n if I'm going to calculate little m. How do I get n using that number? We had a special number that went along with that sometimes, named for the guy who discovered it. Avogadro's number, right? Okay, so what we found was you could calculate the number of moles by taking the number of molecules you have and dividing by the number of molecules in 1 mole, Avogadro's number, 6.02 times 10 to the 23. Okay, if that's how many are in 1 mole, and I divide what I have by that, it'll tell me how many moles I have. So 7.5 E24, okay, divided by Avogadro's number. All right, so I have 12.46 moles. now that I know N and big M, I can calculate M, little m. Yes, Avogadro's number was one of the things on the back side of your periodic table. All right, so now that we have that, now we manipulate and we find that M, little m that is N times big M. So our 12.46 multiplied by our 135 or 136.15, okay, grams per mole or molar mass, right? That would give us our overall mass. All right, so we would have 1,696 grams of this stuff. Well, 0.22 grams of this stuff. Okay. That's as hard as they would get. Like I couldn't give you a mole equation question harder than that. Right? Chances are on the final exam, I probably wouldn't give you as hard a one as I could think of, but there are 3. Right? So you're gonna have to do 3 of the 4 for sure. So do you have lots of example problems in your notes? Okay, on the worksheet booklet, okay, make sure you look over those. And there's a couple on the final exam review package that I gave you on Friday, okay? Well, didn't give you, I put on Google Classroom. So make sure you look over that as well. Okay, and that was the end of chemistry. Okay, that was the stuff that we covered, right? Again, the big mark or big ticket items in chemistry are reactions and the mole equation. So make sure that you can demonstrate your skills at those 2 topics at the very least, right? There's a fair amount of multiple choice on chemistry. Okay? There's 50 multiple choice questions and probably, I want to say 18 or 19 of them are chemistry. Okay? No, 17 of them are chemistry. Okay? So a fairly significant portion. Right? In terms of the whole final exam, guys, it isn't equally weighted. It's close, but it's not like the units aren't equal in terms of marks. Okay, unit 4, okay, the one we're currently on, is considerably less marks on the final than the other 3 units because it's a short unit. There's not much there. Okay, the other 3 are close. Right, chemistry has more marks than physics and bio. Just by its nature, its questions are many parts. Okay, so it's probably like chemistry would be, let's see, what's the whole thing out of it? The whole thing's out of 136, something like that. Okay, so of that 136, probably, I want to say around 40 to 45. No, it's 45 marks would be chemistry. Okay, and then probably another 40 marks would be physics. Okay, and then 30 something for bio, and then like the last 20 something would be your global systems and energy, okay? Somewhere in that neighborhood. So they're close, but they're not perfectly equal. All right, so if you're going to focus on one thing more than the others, focus on probably chem and physics just a little bit more. And remember that how you study for each unit is different. Okay, you study for chem and for physics by practicing your skills. You're going to be asked to demonstrate your skills for those units, so practice them. Be able to solve problems, write equations, that kind of thing. For biology, that's more, I've got to read over my notes. I've got to think of ways Mr. Coderre might ask me about osmosis, okay, or how he might ask me about the effective size on cell transport. How would he word those questions? Okay, you've got to be able to explain stuff in the biology unit and to some extent in this last unit, right? So those involve a lot more reading of the notes and kind of writing things down as opposed to problem solving. Okay, so just keep that in mind when you're studying. Okay, you do have to kind of switch gears a little bit between units. The test is in order. All right, so in the multiple choice, you'll have all your multiple choice questions on chemistry, then all the multiple choice questions on biology, then physics, then global systems. They're not mixed up. Okay, and that's just because it's probably better for you to have a mindset and then a different mindset rather than going, oh, I got a chemistry question and then I got a physics question and then I got a biology question and not being able to get in a rhythm. Okay, so it is broken up, and so is the written response. Okay, the written response is sectioned off by unit. Okay. All right. So yeah, 50 multiple choice, 86 or marks in the written. Okay. What part should you likely do first? Do the written response first. Okay, like unless you're just like a person who has to do the multiple choice first, I would recommend you do the written response first. Okay, the multiple choice will go fairly quickly, but it's better to have that at the end of the test than to have a bunch of questions worth 5 marks each that you know you're not going to have time to finish. Okay, do the written response first. Okay, make sure you get it done. You can always rush or go fast, okay, on the multiple choice part. So just keep that in mind. Okay. All right. Any questions from you guys on chemistry? Anything you'd like me to go over? Review in more detail? What was the one thing I said you needed to come with today? Questions. Remember how I said you're going to get way more out of what we're doing if you have questions to ask?
Can we go over the models?
The models?
Structure of the atoms.
Okay, well, again, the models are not, the models other than the current one are not going to be something that's focused on like / touched at all.
Well, I guess the ones like the modern day.
Okay, so modern day one, okay, the one we currently accept is the de Broglie electron cloud model, right? So I said like on your unit exam, you were asked to draw one of these, and I think it was, let's just pick one. Let's pick beryllium, for example here, okay? So for beryllium, okay, beryllium's atomic number is 4. What does the atomic number tell me?
How many?
Protons and
Neutron?
electrons. Tells me protons and electrons because those have to balance each other out, right? The net charge has to be 0. So I would go 1, 2, 3, 4 protons. And I would like go equals protons, right? And then I would go 4. Okay, I'm still missing neutrons. How do I figure out how many of those there are? Exactly. I take the atomic mass and I subtract the atomic number. So I take 9.01 and I subtract 4. Right? That means it's going to be 5 neutrons. I'm done. I just drew the de Broglie model, okay, of beryllium with all the correct number of particles in their proper places, neutrons and protons in the nucleus, electrons in the cloud.
Do you have to label it like that?
I didn't say I was going to ask you to do that. Okay, so that's models. Okay, what else? Yeah. Combustion reactions? Okay, so the big thing with combustion reactions is you're always going to have some hydrocarbon, so some compound that contains a certain number of carbons, a certain number of hydrogens. It's always going to be reacting with oxygen because without oxygen you don't have fire. Okay, the products are always the same. They're always carbon dioxide and water. Doesn't matter how many carbons and how many hydrogens there are, the products are always carbon dioxide and water. All that changes is how much carbon dioxide and water. Okay, so again, the balancing goes in alphabetical order, and there's the rule of 2. Is this an even number? So then I apply the rule of 2. Okay, if this was instead C5H12, okay, plus O2, then I would not apply the rule of 2. Okay, so when we're doing this, I have 20, so I put a 20 here. Okay, I have 44, so I would put 22 there. Okay, I'd have 40, and 22 is 62, so there would be 31 oxygens. Okay, but if this one here, I don't need the rule of 2, right? So I just go 5 carbons, 12 hydrogens, 6 times 2 is 12, 5 times 2 is 10, plus 6 more oxygens is 16, 8 oxygens. Right? 8 times 2 is 16. All right, so it's always the same kind of formula to get it done. All right, what else? Yes. Like you mean a compound? Okay. So big thing to remember, this is properties of compounds here. So let's just maybe make a chart, okay? Ionic compounds, okay, and molecular compounds, right? Ionic compounds are always crystalline solids. Try that again. Okay, always. Molecular compounds can really be anything. There are some crystalline solid molecular compounds. There are liquid molecular compounds. There are gaseous molecular compounds. So they could be any state. Okay, ionic compounds are generally soluble, often highly, whereas molecular compounds tend to be less. Not always, but they tend to be less soluble. The one test that we did that always told us 100% of the time ionic or molecular was what test? Conductivity. Okay. Okay. Solutions non-conductive. All right. Ionic compounds can contain strong acids and strong bases. These ones tend to be weak. Okay, because to be a strong acid, you have to be able to dissociate, that is, split into your positive and negative parts, which is also why these solutions conduct and these ones don't. All right. Now, the other thing with the ionic compounds was, okay, their solutions could be colored. All molecular compounds have clear solutions. Okay? But with our ionic compounds, okay, if we had red, it contained cobalt. If it was green, it contained nickel. And if it was blue, it contained copper. Okay, so will that help a little bit with the identification? Okay, so that was lesson 4 in the chemistry unit, so might not be a bad idea to read through the notes for that one, just to kind of refresh that part. Okay, what else, guys? Luke? Okay, different mole equation question? Okay, so how many moles of magnesium hydroxide are in 75 grams? Okay, so we're looking for N because the question wants us to find the number of moles. Okay, they told me the mass is 75 grams. In order to calculate molar mass, I need to take the name and put it into its formula form. Right, so magnesium is Mg, and hydroxide is a polyatomic ion. Now, magnesium has a 2+ charge, while hydroxide is a -1. So what do I have to do with this? Okay, like this? brackets, right? This is not the same thing. Okay, that says there's two O's and two H's. If all I do is put the 2 there, there's one O and two H's, and that's not magnesium hydroxide, it's something else. Okay. All right, so now that I have that, now I can calculate molar mass. So for magnesium, that's 24.31. There's only one magnesium. Okay, there are 2 oxygens, and there are 2 hydrogens. Right, so that will get me my molar mass. All right, so 58.33 is my molar mass. Yes, Jason. Yep. All right, so now that I have big M and I have little m, I can calculate N. So N equals little m over big M. Okay, I don't have to manipulate it. I just have to put in my numbers. So 75 divided by 58.33. And I've got 1.29 moles. Okay, that's the easiest one. All right, what else, guys? Okay, well, if there aren't any, more will come up. So what I want you working on right now, open up the final exam review package. Okay, and there's a whole bunch of chemistry stuff here. Okay. All of those questions have at some point been on the final exam. So I would say for right now, that's what you should probably be working on. All right, the answers are in bold, okay, at the end, so you can check your answers as you go. Okay, yeah, let's have you get going on that for now, and then hopefully more questions will come up and I'll answer them.